Okay, well, as long as that last section was that we did, that 13.3 with the unit circle and the whole deal. 13.4 I'm hoping to make relatively short. I think it's a lot of stuff that you've done before. Inverse sine, when we say the word inverse, we mean kind of the undoing of something. So if I had 5x equals 10, we would multiply both sides by the inverse of 5, which is 1/5. And we would get x equals 2. And it was kind of undoing of 5. When we do the sine of theta equals 5/7, to find theta, we're going to do the inverse sine. And the inverse sine is on your calculator right above the sine button. You just do second sine. So if I do inverse sine of both sides, the sines cancel out. The inverse sine, the sine cancel out, and I do the inverse sine of 5/7. That's the same thing for the cosine and the tangent. When we talk about inverse sines of trigonometric functions, when we're dealing with certain areas, it's going to get a little shady, and I don't know how best to say that, but if you look at the inverse sine of something, the inverse sine will work in all of these areas right here. But because a smart trig class knows, because sine is positive here and here, then you could get the same answers for 10 degrees as you could for 170 degrees. They'll end up being the same answer on your calculator. So that's going to create a problem for us, and we'll work with that. When you're dealing with the inverse cosine, all the way from 0 to 180, you're fine. No problems at all from 0 to 180. And generally, that's what we're dealing with because we're dealing with triangles. And on tangent, when you're dealing with inverse tan, you're dealing with the same kind of a scenario as you're dealing with the sine. So because they're both positive here, positive, remember it's sine over cosine when you're dealing with it. So that's when we're asked to find the inverse cosine of something like 3. If you put inverse cosine in your calculator, there's no angle whose cosine is 3. So the inverse cosine of 3 is going to be undefined. That's not going to work out for you. Okay? Remember, when we find the cosine of something, so if I said the cosine of theta equals 3, remember what we're dealing with is that unit circle. And because the unit circle goes from, on the cosine, on the x's, goes from 1 to -1, your answers all have to be between 1 and -1. If they get any bigger than that, then they end up being, undefined. So once we have that 3, then we're in the realm of undefined. The inverse tangent of the square root of 3 over 3 is one of those things that you were supposed to memorize, is the square root of, or is pi over 6. Okay? Or 30 degrees. Okay? Now that's a tough one. Now remember what we said was sine, sine over cosine and all that stuff. That's something you can just put into your calculator, and if you're in tangent mode, it will just come out 30 degrees. If you do the inverse tangent of the square root of 3 over 2, again, you could just put it in your calculator, but it would be pi over 3 or 60. Go ahead and do that. Go ahead and do the next 2 by yourself. Alright, hopefully you paused that and tried those. The inverse cosine of 1/2, essentially, or -1/2. That would mean I did the cosine of theta equaled -1/2. Well, the cosine of what is 1/2? Well, the cosine of 60 is 1/2. However, the cosine of 60 is 1/2, but not -1/2. a smart trig class knows that 60 over here would create that negative cosine. Alright, so that ends up being 120 degrees. Or if I did it in radians, it would be 2 pi over 3. Okay, and tangent, inverse tan, where am I going to get a 1 or where am I going to get a negative 1? Well, a smart trig class knows that tangent is positive down here and up here. It's negative over here. Okay, where am I going to get a 1? Well, remember it's sine over cosine. So when are sine and cosine the same? Well, they're the same at 45. Okay, sine at 45 and 45 are the same. And so what we're dealing with here for negative 1 is 45 degrees over here, 135 degrees. We also would accept negative 45 degrees. Both of those places would work. And negative pi over 4 or 3 pi over 4. Those are all possibilities. And on the last page of our notes, that's nice to say, isn't it? Solve the equation cosine theta for 2/5. 2/5. If I put that into my calculator and I just do inverse cosine, 2 divided by 5, make sure you put parentheses around the 2 and the 5. You're going to get 66.4 degrees. Alright? This angle is in quadrant 1. But they wanted something in quadrant from 270 to 360. They wanted something in quadrant 4. 1, 2, 3, 4. And it's cosine, and it's positive. So a smart trig class knows that cosine's positive down there. Remember that whole butterfly thing? If it goes 66.4 this way, then it's got to go 66.4 that way. So I'm going to do 360 minus 66.4. 360 minus 66.4. And I'm going to get 293.6. All right. Find the measure of angle theta here. Well, if sine of theta is opposite over hypotenuse, 5 over 13, so I do the inverse sine of 5 over 13. This is very similar to what we were doing in geometry class just a year ago. And I get 22.6. Okay, you take a moment and do those two checkpoints. Alright, welcome back. Now this says anything from 90 to 270, the sine of 0.7. Anything from 90 to 270. Well, if you put that in your calculator, you end up with something like 44.4. And that was over here. Well, that was not from 90 to 270. So a smart trig class knows if we're talking about sine being positive, we must be talking about over here, and it's got to be 44.4 up from 180, so 135.6. And find this angle. Well, if I have opposite and I have adjacent, I'm going to use tangent. You may have wanted to do a squared plus b squared equals c squared and find hypotenuse and then use sine or cosine. But I'm going to use the tangent of theta equals 5 over 8, or theta equals inverse tan of 5 over 8. Alright, and when you did that, I hope you got 32 degrees. Make sure your calculator's in degree mode. And that is all for section 13.4.